criticality is not a geological problem. It's a geopolitical and optimization of supply chain issue where concentration at all the different stages creates bottleneck that might be out of its comfortable spheres of influence.
Hello and welcome to the Elements of Deep Sea Mining. I'm Eric Young. If you've been following this podcast or the news at all, you have heard the term critical minerals being used everywhere. Ukraine, Greenland, tariffs, trade wars, it's become central to how we talk about geopolitics and the energy transition. But what does the critical part actually mean? I wanted to do an episode on exactly that, what makes a mineral critical, who it's critical to, and what that label is actually doing. My guest is Pierre Josso, Deputy Director of the UK's Critical Mineral Intelligence Centre. Pierre helped build the UK's critical assessment methodology, and I really appreciate his framing that criticality isn't binary. It isn't the same for everyone. It doesn't take place at any specific point in the supply chain. Also, that the threshold between critical and not critical is not a technical decision, but a political one. Also, I found it valuable that Pierre emphasizes the whole exercise is fundamentally a communication tool for decision-making, and that criticality is rarely a geological problem, but a problem of supply chain concentration. This is a very detailed conversation. We get into how criticality is measured, where the data limits are, and how different countries reach different conclusions about the same materials. Finally, Pierre also has done substantial work on deep sea mineralogy, nodules, crusts, and sulfides, and we touch on his research in that field later in the conversation. Without further ado, I bring you my conversation with Pierre Josso. Welcome to the Elements of Deep Sea Mining podcast. Pierre Josso, thanks for being here.
It's a pleasure to be there with you.
So Pierre is Deputy Director of the Critical Minerals Intelligence Centre at the British Geological Survey. Pierre has a background in deep sea geology, published on the mineralogy of manganese crusts, and worked on other deep sea mineralogy topics. But Pierre was also instrumental in developing the UK's criticality assessment methodology and the critical minerals list. Is it a critical minerals list or a critical raw materials list for the UK?
Well, it depends because effectively not all the materials that we've assessed are minerals to some extent. So because we're evaluating a large range of things, material elements, some are gases, some are industrial metals.
Yeah. Well, I'm probably going to use the term critical minerals a lot because it's one fewer word than critical raw material. The reason that I've invited you here is to explain what criticality means. So let's just start with there. What is criticality? What do we mean by critical minerals? It's a super common term. I'm sure that you see it becoming more often referenced in big news articles. So yeah, let's just start by explaining to people who are interested in deep sea mining, which is the audience of this podcast, like what do we actually mean by criticality?
So criticality would be an exercise that is quite close to risk management approach. And effectively, you can do that at different scales and scope. For a person, a company, an industrial sector, a nation, a group of nation. And it's an exercise that tries to evaluate the economic importance of some of the processes or materials that are involved into your economy or into your business, effectively, depending on what scale you operate at. And we try to evaluate how resilient your production process, your economy is to a potential disruption. So we look at economic importance as well as global supply risk.
Right. So it's how important is something to somebody and what are the chances that you're going to lose access to that something? And then you can look at that at different scales. People most often talk about them at the national scale, but you were saying earlier that they also do it at more global, like you said, they've done a NATO. Does NATO have a critical minerals list?
So various sectors have done their own assessment. Effectively, we know public lists exist for instance, for the defense sector associated with NATO. We know the critical metals associated with the energy transition from the perspective of the US. The Department of Energy has done a critical mineral list for that. But there is also the USGS, Critical Mineral Evaluation, which looks at the big picture from the whole US economy perspective. So effectively, there will be some sense of overlap between those two lists because the energy sector is part of the US economy, but it will be weighted against all the other manufacturing and consumption area of the US economy. And this is where effectively we warn people when they say to us, well, your list is listing X, Y, Z as critical, but that material for us is absolutely essential in our manufacturing process, and you haven't listed it as critical. And we tell them, well, this is because whilst it's essential for you at the scale of your company, when you consider your company within the scale of the exercise that we're doing at the scale of the nation, it is completely overbalanced or overpowered by other consumption areas or manufacturing sectors. It doesn't mean your specific needs are not critical at the scale of the nation, which is one of the problem that there is effectively with those assessments, is that they're not perfect.
Yeah.
They cannot capture everything because all materials that we use have a purpose. Industrial minerals are absolutely essential for our daily lives, for building our infrastructures, but because they're so abundant and locally produced more often than not, they are not considered critical. But for the company that exploit them and the construction sector, this is their bread and butter. They need that.
Yeah.
But from a risk perspective, it is minimal. Whilst on the other side, some of the materials that tend to be criticals will be your technology metals, because this is one of the major driver of economic development. So renewable sectors, the construction sectors, aerospace and defense, electronics, consumer products are usually the major sectors that are of importance in an economy. But this is where we start seeing some differences as well between the different countries that do those exercises and how their economy is, whether they are consumers or producers.
It seems to me like it makes sense that there's this dimension of importance, this dimension of risk, vulnerability, and then occasionally there's also a third dimension, or at least the Yale methodology has this third dimension of environmental, which I'm not actually clear whether that's environmental importance or environmental risk.
I think it's environmental risk to some extent associated with the production of different elements. But that starts asking questions. So your question really starts two lines of inquiries: is how many dimensions do you put into a criticality assessment? Effectively, all the different metrics that goes into the assessment of economic importance or global supply risk, you can put as many as you want, and you agglomerate them to kind of come to indices or indicators that you can plot into a two-dimensional diagram.
Yeah.
Because this is an ease of communication with the public, industries, and policymakers. But effectively, in that view, adding more dimension, whilst it's from an analytical perspective correct, it makes understanding the analysis that much more complicated for the general public.
Yeah, I think that's super key, is that at the end of the day, these are for ease of communication, of expertise into decision-making or something like that. And so, So I'm interested in how we quantify the different aspects. I want to get your explanation of like the different ways that we could quantify economic importance and supply risk or vulnerability. Let's start with economic importance. So it could be how important is something to GDP of a nation. I guess that would be one way that people would quantify it. And then you've already mentioned that there's also this kind of element of strategic sectors. So like, even though defense doesn't exactly show up as maybe one of the biggest GDP sectors. But it's critical to underlie the rest of the economy, and then maybe explain the way that you eventually settled on for the UK method.
So it's really important to highlight that those are subjective metrics. And effectively there is, compared to a lot of mathematical or geochemical, geological processes, there is no one agreed way to do something. So effectively, we are continuously improving the methodology, the data that sits behind those assessments, the resolution that we have. So in the last assessment that we did, we were for qualifying the economic importance of a material. We were looking at the contribution that the manufacturing sector using this element was contributing to the global economy. So that's what we call the gross value added.
To the global economy?
Well, the global economy of the country.
Yeah, sorry. Yeah.
So what we call the GVA, global value added.
Okay.
We were looking at the net import reliance. Are we ourselves producing that material and consuming it? Mm-hmm. Or are we completely dependent on imports for our own consumption?
Still in the economic?
Yeah, because there will be, to some extent, a trade balance between your import and your exports. Mm. And you can look at that from a value perspective as much as a mass perspective, which will tell you different things for the same commodity. Because effectively, you need to do both exercise of mass and value, because elements, material, comes in a lot of different flavor. For instance, if we look at titanium, you can bring it as rutile. You then can bring it as titanium dioxide, which is what you use for paint. It's the white pigment in everything.
Ice cream?
Well, I hope a little bit, probably, sadly. And effectively, that titanium dioxide is about 80% of the global titanium market. And then you have titanium metals at different levels of purity, titanium alloys, titanium sponge, which is then after that, what is being used for the manufacture of high performance alloys. And often the criticality comes from those very specialized high purity, and effectively it's a small mass, but high value.
So you are trying to assess how important a material is to a sector, and how important that sector is to the economy that you're looking at.
And at the moment, we are working in developing even further that methodology. We'll produce a report that will be public. We try to make most of our research public to help others bring their understanding of their own criticality of supply chain forward. Yeah. And we are integrating into economic assessment and economic risk, to some extent, market sentiment. So effectively, price volatility is a very complex thing. Markets effectively can be manipulated. They can be oversupplied. There can be a lot of liquidity within it. So we've developed a series of 7 different metrics on analysis of price series to effectively capture different aspects of the frequency of outbreaks or downbreaks from a normal market-driven approach, whether it's supply or demand, and how tight a market might be. And that allows us to add another layer of understanding of risk as to how quickly prices can go up or go down, crash, be manipulated. So that's one aspect that we're improving. We have partnered as well with the Office for National Statistics of the UK to get access to much more higher resolution economic data on the different sectors of the industry. And they've provided us with a fantastic data set to allow us to map how different sectors contribute and rely to other sectors of the economy. Yeah. So effectively, before that, we were exploring the manufacturing sector, how making steel, how does that contribute to the gross value added? Yeah. But that's just one starting point. Effectively, that steel is then used in the construction sector or the aerospace sector. Without the manufacturing of steel, you need to import that high performance alloy to make your aerospace engine. So effectively, we now are capable of evaluating the economic importance across the different economic sectors and how a disruption to down the supply chain can impact downstreams. Yeah. And vice versa, how an increase in demand in a finished product, you say you want to increase massively the production of your engines to supply the market for various application. What is the supply dependencies and what are all the sectors you need to increase your consumption of energy, of various chemicals and other manufacturing processes. So the dependencies on both sides. So we are in the process of trying to qualify that.
So it sounds like your methodology is actually very complex.
It is.
So I'm somewhat familiar with the EU methodology, which I know that they kind of wanted to make it transparent and workable enough that kind of people could replicate and use it to do their own analyses of their own industry or whatever according to their methodology. And that obviously brings along whatever compromises, I guess. And the one that bothers me for the EU methodology is just the economic sector. Like they use the NACE codes for economic sectors, which is like a standardized statistical classification of economic sectors. But it isn't exactly like it classifies things into sectors according to a standard which is probably to do with ease of reporting and ease of data aggregation, not at all intended for the purpose of like, do these sectors kind of make sense? Do we draw the lines between these sectors in a way that makes sense according to what materials they use and how they interact with one another? What really bothers me is that they take how much a material goes into one sector as one of the big weighting criteria, and then how important that sector is. So if you have a material that is mostly used into a very high GDP sector, that material becomes very important. But if you take even more of that material and you start using it in a low value sector, then its importance would go down. So that's, I guess, mostly to say the EU methodology made compromises based on, in order to facilitate kind of workability and transparency.
It is an incredibly complex exercise. And as I said at the beginning, none of the assessment is perfect. We can only work towards improving them. What the EU is facing is the scale at which they're doing it. Effectively, they have to consider 27 economies, and that is incredibly vast. All the trade that goes in between those countries, the import-export on all of those countries, it's a data exercise and compilation which is incredibly difficult. So there is two sides of this. There's effectively the requirement for making the exercise manageable. And effectively, there's also the data wall. Do you have the data to go further down into the details? Is that data actually existing? Is it available? And is it homogeneous across all the different metrics that you use, so that you don't have a single metrics that evaluate something very, very precisely, but then all your metrics are very largely aggregated and at a scale which doesn't compare, and therefore you could question aggregating those two together because it's comparing apples and oranges. So like in many other sectors, when you do modeling, for instance, whatever it is, you usually adopt the resolution of the lowest resolution data that you have. And this is why often we are limited into the quality of the data that we can do, because also most of the trade, the import, export, the consumption is not necessarily reported. And this is why in the work that we currently do, as I said, we're trying to keep pushing to get better resolution, finding partners that can improve the recording of the data so that we can use it. It's our job to tell them, if you want a better assessment, you need to tell companies, industries, countries to record the data in a way that is usable. And there is, at the national, international level, a push forward into that.
So, so then is the UK methodology is transparent and open? If I were to dig into it, I could try to understand it. It's just that there's you using multiple metrics, and I would have to really work at wrapping my mind around those.
The EU methodology, to some extent, is also transparent. A lot of the starting point for the UK methodology was based on the EU, because pre-Brexit, the UK was participating into the first criticality assessment at the EU scale since 2011. And effectively, this is also this experience that has allowed us to produce the UK assessment in the way we've done it. But we consider that there's a lot of very good things that are part of the EU assessment, but we've just pushed them further because at the scale of just the UK, we had better data.
Better data, interesting, great. Okay, then let's move on to the supply risk, the vulnerability side. How do you quantify that?
So similarly, I'm going to talk first about how we've done it and how we are trying to improve it.
Cool.
So effectively, we're trying to look at all the different moments in the supply chain where you have an influx of the materials that you need. So that means we need look at obviously the primary supply chain, which are the primary production, so mining, refining. So we look at how diverse the mining sector is, the refining is for each commodity. And that creates, you can easily derive a concentration index.
Yeah.
So a commodity which is produced across 50 countries will be likely to be considered weighted, obviously, against the different volumes, will be considered very diverse. If a country were to stop the production, that would not have that much of an impact on the global supply. Inversely, a commodity which is produced into a handful of countries or just one country, if there is a change of legislation, quota or export control that is put in place, suddenly that impacts everybody. So we look at that at the mining level, the refining level, and then through the analysis of trade data, tracking the different forms of those materials, as I was saying earlier, for titanium, as an example, we look at which country consume the different forms and create also an indicator of trade concentration as a form of saying if that country might not be involved into the mining, the refining, but then is gathering all the resource from across the planet for the manufacturing of a specific component, that is also a bottleneck. That is also a high risk of potential supply disruption.
And you quantify all of this, you sort of assign all of this back down to the material. So you say, okay, titanium is the thing that even though actually we care about multiple different titanium products, or rather we care about multiple different forms of titanium in multiple different products. Those are all entering the UK at different stages of the value chain. You're already sort of mixing in all of these things. Do you manage to separate out like the supply risk for this stage of the value chain is whatever low, and it enters into the economy at that low stage? Do you like combine the supply risk and the economic importance at the different stages of the value chain?
Well, this is where effectively each of those different metrics try to capture different stages of the supply chain. And effectively, we combine them to highlight how a bottleneck at one stage can create a major problem. So we have a mathematical way, which is another improvement on the way others have done it, which amplify extremes rather than averaging. And effectively, if you have everything which is very diversified, but one stage in your supply chain which has a single point of failure, for instance, or a very heavily concentrated side, that will bump up very highly the score for that metric.
Yeah.
So those aspects are very much what we call the upstream, so the primary production. We look also for global supply risk at the capacity of recyclability.
Okay.
So effectively, then you also hit a bit of a wall of data because you only have recyclability of metals at a global level or within specific industries. But if a metal is easily recyclable, then that will lower the overall supply risk. Whilst if we know we can't recycle it or it's not done at the moment, everything is recyclable with enough energy.
Yeah, right.
So that's another aspect. And we also look into the supply risk at whether the materials that we look at, are they co or byproduct? Effectively, is the production of that element at the mining stage a primary commodity, your iron, your copper, your nickel, your aluminium, or whether the elements are byproduct, and effectively their market is to some extent driven by the production of another commodity.
Right, so that is somehow related to how responsive the production can be to scarcity.
Exactly.
I'm just thinking as you're talking about, so we're recording, what are we, the 12th of March here, 2 weeks into the war in Iran, and right now there's stoppages of oil through the Strait of Hormuz, and this is causing price fluctuation. So that is not really a supply issue, it's a transport issue. I guess the question I'm getting at is are there things that you haven't managed to get into the methodology that you think you would like to? It's just too difficult.
Yes, absolutely. So what you're touching on with the example of the war in Iran is effectively it's not a production issue, it's a capacity for an actor to intervene into the trade.
Right.
Whether it's through closing completely a trade route or effectively putting a quota on exportation or inputting tariffs on import or export of those things. Those are effectively much further down the chain of the supply chain, but they can happen at any stage of transformation of a product. So that's something we're trying to capture through the characterization of trade concentration. But effectively, if the trade route passes by a nearby country which might be hostile, that is a whole different things which we try to capture, but it's very difficult. There's a lot of different improvements. We effectively talked before on production concentration and how it might be concentrated into one country or effectively spread across multiple countries. Well, that is a very imperfect way of measuring it as well, because you also should consider company level concentration. Right. Because if you have production which is spread across multiple countries, great, it's diversified. But actually, it's only one single company that operates all those deposits across those things. So it's another dimension of concentration.
And have we seen that actually? So the examples that get brought up in terms of supply disruption, the ones that come to my mind are kind of either when China turns off the tap of rare earths or of whatever it was, gallium, when they got into a fishing dispute with Japan, or when Indonesia turned off the tap of nickel ore production. And then, people talk about, okay, but these companies are owned or I've seen metrics around like shareholder interest and whether that concentrates in a country. And I've never seen how that actually has manifested in all of the shareholders, majority in all of these different companies happen to be, usually it's Chinese. And so does the Chinese interest somehow put pressure through that? Has that happened, I guess, is my question,
The answer is absolutely yes.
Yeah.
So we see that at a higher level, whereby the reason China also has that monopolistic situation on the refining is not because, it's partly because they have the capacity, first and foremost, and low energy cost, and a lot of the cash flow is brought by the state. But effectively, a lot of producing nation will send their ore to be refined because the company that is mining the ore is partly owned by China. So they are offtake agreement already that whatever you be producing, we will recover X% of production to be refined in China, and therefore they will gain control over that. The Indonesian nickel example you mentioned is another one. Effectively, it's Indonesian nickel, but it's produced by China funding effectively. And so effectively, we saw a massive increase in nickel production that completely drawn out the price. Price fell down dramatically to prevent, that was a deliberate action to prevent other companies operating across the world to have a selling price that allowed them to operate.
Right.
Completely crashing competition, and then you can restart your production, lower the volume, and effectively gain, again, market dominance.
Yeah.
So market manipulation like that are fairly well known. Rare earth is another one, but it is the same for graphite, magnesium, gallium, germanium, tungsten, and so on.
And this this goes in the opposite direction of what I tend to think of when I think of supply risk, is I think of someone turning off the tap. But these examples are market manipulation to kind of turn on the tap, drive away competitors, and then dominate the market, which then gives you the future possibility of turning off the tap.
Yeah.
Also.
Absolutely.
Do you also take in expert opinion? You must interact all the time with people in the different industries who say, okay, your assessment doesn't capture this, but we can explain to you that it's actually a really important dynamic. And I think, for example, the Canadian critical minerals list, at least a few years ago, when I asked what their methodology is, the answer that I understood that I got was, well, we talked to the stakeholders and have made this list based on input, which, I mean, frankly, seems like a reasonable approach also. So just, tell me about how you incorporate the additional sort of knowledge.
So we do effectively try to interact with industry. We effectively have different panels that allow us to interact with various sectors, whether it's the chemical industry, the automotive sector, aerospace, construction sectors. And we do get their feedbacks effectively. Often what we get is the specific elements or material that they need for their input, which they're struggling with, which is absolutely fine, and we can incorporate that. But effectively, that is also a tiny part of often what they lack in visibility about all the other reliances that they have on necessarily, for instance, the machine that they use for the manufacturing sector is not necessarily the input that you transform, is what you use to transform that. And so we have quite a lot of very good data already on what each industry has and consume. That is publicly available. The EU did a fantastic job on the Screen project, effectively to try and map that out. So we use their data to some extent. We push it further when we can and complement it. And we feed back some of our data back to them. We do consider these, obviously, inputs, and that bring us back after that to the scale and scope notion, where what might be essential for one industry is potentially drown into what the global economy looks like.
Yeah. It sounds like that's a two-way process when you talk to industry. You're getting what they, you're hearing from them what they recognize as critical, and you're also helping them understand their own supply chains and what they're kind of missing.
So in those interaction, what we've quite commonly found is that effectively they will have good visibility on their tier one suppliers, so the people that they buy from directly, maybe tier two, who their supplier buy from, but after that, it's absolute black box from their perspective. And when you engage with very large equipment manufacturers, they are mostly assemblers of the different parts that have been produced all over the planet. And some very large companies may have tens of thousands of tier one suppliers that have themselves 10 or hundreds of tier two suppliers and so on. So it creates an arborescence, a tree of supply chain, which is incredibly difficult. So you cannot do the super detailed case-by-case basis for a criticality assessment at a national scale. You can do those exercises at the industry level, and this is to some extent a work that we've done for some specific technologies. Also,
I have encountered that businesses can't get the information from their suppliers. We encounter this all the time in sustainability analyses when we're trying to do a life cycle assessment for a company. We say, okay, what are your inputs? They give us their invoices of who they buy from, and we say, okay, and what are their inputs? They won't tell us. That's
sensitive data, potentially.
Yeah, right. So often the reason that things are obscure beyond one or two levels is often just that people aren't going to share that information with one another.
And it's an administrative workload that is incredibly heavy as well. The EU tried to pass legislation on that, and there was a massive fight back from industry saying, if you put that regulation in place, it's going to create an overburden on everybody, which is always going to be pushed down the supply chain, because tier one wants to know what tier two does, so tier three needs to inform, so tier four, and it goes everywhere.
Yeah.
And you go down to smaller and smaller supplier, small enterprise and companies that just do not have the capacity to monitor those kind of things at the level that is required by the big manufacturers. It's not applicable. This is the data wall of what's achievable.
Okay, then let's talk about the threshold of what makes something critical or not critical.
So this is an interesting difference, effectively, as to where I would say, the science of and the methodology of creating all those metrics and scoring them stops, and where the economy and policy starts. Because effectively, what a criticality assessment essentially does is ranking all those commodities from the least critical to the most critical. It's a continuum. Everything is important to a certain. But if you go to policymakers and you say everything's important, they will not be happy. So after that, you start effectively a discussion process as to what do we prioritize? Where do we put that hard limit between the least and the most critical? And effectively, how much input can you influx into the system to help reduce the criticality of that subgroup you've defined as your priority targets? So this is what it is at the end, putting the limit, the thresholds on economic vulnerability and global supply risk at that level or that level is a discussion. Effectively, it's a prioritization exercise to say if you put it too low, you have too many elements that are critical, your efforts to de-risk is going to be scattered around and you're not going to be able to make too much of an impact. If you only focuses on too few, then you still have too many industrial vulnerabilities.
So this ties back into what you said earlier about how this is, at the end of the day, a communication
Absolutely.
tool. What people, I think, see a lot of is there's a critical minerals list, or sometimes there's a figure where things are mapped in 2 dimensions, and there's 2 lines, or in your case, a curve. I imagine that there's room for more levels of communication here. So you could present just kind of the list of more or less critical, and then you could present also according to different dimensions. Like, do you sometimes, when you're actually working with people on these topics, you say, okay, well, first we're going to just talk about the economic importance here. We're going to help you understand that dimension separately, and then help you understand the other dimension separately. We've talked about how you kind of have to aggregate a whole bunch of important aspects into 2 dimensions and then kind of into 1 dimension and then put a threshold. But is it easy to break those things apart into less aggregated and then an even less aggregated?
So we publish in our reports all the score for each indicator. So effectively, you have the global supply risk score, you have the global concentration, trade concentration, the recyclability, and all those metrics are scored. So effectively, you can easily do an analysis of this table of metrics, and effectively, they all contribute differently to the final score of a dimension. And effectively, it's also helpful to have that visibility, that granularity, because something that has a high supply risk, well, 2 elements that have a high supply risk may not be plotting that high for the same reasons.
Right. Yeah.
So effectively, this is an aggregation exercise for communication, but behind it, there is the decision making is informed as to how you want to address that risk, is informed by which metrics actually scores the highest. And effectively, as I said, you may have a bunch of metrics that are fairly low, but one, which is the bottleneck. So this is where you need to put your action into. So we do give that information to policymakers and advise them as to, if you have a major problem with one commodity, the way you're going to deal with it is not going to be the same as another one.
Yeah.
So effectively, you can be critical, but not for the same reasons.
Yeah. So that's interesting. So that goes to the next step, which is this is a communication tool. Absolutely. In order to enable action. So which actions you can take, or you can drill down into the methodology and kind of pick out things. Yep. That's super useful. I guess quickly just mention whether or not these methodologies tend to be forward-looking or kind of snapshot of the current picture.
So all criticality assessments that are currently published and used across the planet are expired. Well, the ones that are mostly data-driven will obviously rely on past data for the last potential 5 years. So they present you with what's the situation today or over the last few years, effectively, which therefore is another major critics of criticality assessment, is that effectively is like, but what are we going to need into the future?
Right.
And having had to deal with those very pressing questions from policymakers and industry and effectively trying to answer them is impossible. Everybody would love to know what the future is going to be, what production is going to be, what technology is going to appear and dominate the market, what new geopolitical crisis we're going to be facing. It's impossible to predict. The last 5 years, I've seen such an incredible expansion of the trade, the geopolitical interventions, the amount of conflict that have impacted markets, the trend in technological evolution, the materials that we use and develop are evolving so quickly, it's impossible to predict what is going to be needed. We know a lot of the consumption, the demand is going to increase for a lot of metals. There's only a handful that is going to go down because they're mostly pollutant that we're trying to take out.
Like lead, yeah.
Like lead, like arsenic, mercury, and so on. But at the same time, we can only do forward-looking, like foresight exercise. In a sense, we know that there is a policy trend that is pushing the creation of those new technology, the deployment at large scale of different electronic equipment that we use in our daily life, energy-related applications, solar panel, wind turbines, electric engines, nuclear sectors, and so on and so on. Similarly, aerospace is going to become more and more important, has the attention of a lot of nations is turning towards exploration of space. All those applications, we know to some extent what the research is saying. Now, this is promising, this is promising, this is promising. There's potentially 10 to 20 different types of chemistry we know are potential candidate for production in the next 20 years. Which one is actually going to become the dominant one?
Yeah.
They all have very different chemistry and structures. It's a divination, reading into your bowl exercise that we fear is very difficult to implement into a criticality assessment exercise, because although you may know demand for a certain metal is going to increase dramatically, if you put a future-looking metric against the current metric, you're going to bias it because you don't know what those metrics are going to be at the time you're projecting for that future demand. A lot of people are very worried, and rightfully so to some extent, about future copper production because we know exploration is struggling to find the next big deposit. And a lot of people predict a shortage, but history tells us that we've been in that situation many, many times before, and reserves have constantly increased and matched with production. So from a historical perspective, we tend to say, yes, there is a pace of increase that is required, which we've never seen before. But so far, most commodities, we've never run out of them. We've always been able to expand the reserve base. And this is also a communication exercise that a lot of non-geologist audiences struggle with, is that the reserve and resource are economic entities.
Yeah.
They're not finite at all. We keep on expanding. We've never had so many resources on the planet, effectively. But we also appreciate that we are on a finite planet, and concept of having a finite environment mean there is a limit to the development and valorization of mineral resources or any other material that is considered non-renewable, at least on human timescales. But as long as materials do not leave Earth, they still are, to some extent, part of the systems. And this is where you reach the stage of valorization of waste. This is exactly the same thing. To some extent, metals are the most recyclable material on the planet.
The other piece in there that comes up is just the shift that economies, technologies do when there is a shortage. I mean, again, there's talk right now because of this oil shortage about how this is going to drive movement towards renewable technologies. And I feel like this is a big part of all of this, especially minerals criticality, especially in the electric vehicle case where it's like, well, because we are worried about cobalt, then we're going to shift towards
NFB.
Yeah. chemistries that rely on less cobalt. And so there's a feedback loop built in where if you are short of something, in order to meet your projected demand, you're going to modify the things that create your projected demand.
You'll find an alternative.
Right.
Industry and engineering has been always very good at this. And effectively, cobalt was perceived as a problem, potentially a few years back. But now we are in a situation where companionality is considered into the criticality assessment, is because cobalt production is not, you don't have a cobalt mine, you have a copper mine. And effectively, because copper is the backbone of electrification, we are going to need so much copper in the coming future that effectively DRC, which is one of the largest copper producers, but effectively by de facto the largest cobalt producer, they are oversupplied on cobalt. Because they produce so much copper, cobalt comes with it.
Yeah.
So the cobalt market currently is flooded. They've put export restrictions and quotas to try and restructure the price of the market on cobalt, and they're trying to develop effectively value added in country so that they can get a better value as well for their extractive industry. So to some extent, there isn't really a cobalt problem. And the shift to LFP is also driven by the sheer price of these commodities. Yes, you're doing a trade-off between energy density, and an MC battery is more performant on absolute metrics than an LFP batteries. But then this is also a consumer perception issue as to what we call range anxiety. Do you really need to be able to drive 900 miles or kilometers in one go? Well, I don't know. Most 90% of the transport is short distances.
Yeah, and if the dynamics of supply chains mean that electric vehicles end up having shorter ranges, then the infrastructure is going to respond to that. Exactly. We're going to have more frequent charging stations. And I think one of the values of having this conversation is just to try to put a light on how complex all of these things are. It's not just like, okay, someone did a criticality assessment, cobalt is critical, let's go mine the deep sea for cobalt, because it's like, well, no, all these things are there's so many factors. I think, again, it's that point about how it's all comes back to communication, because in any forecasting study, you're always forecasting based on your assumptions.
Yeah.
And so then you need to find a way to communicate those assumptions in a way that the audience will actually kind of absorb, which I think is always difficult.
So has the director of CMIC, Gavin Mudd, often say, it's a lot easier to predict the past. And effectively, it's a very interesting exercise that we present to people to tell them the complexity of predicting the future and doing foresight analysis. That when you go back 5 years ago, 10 years ago, and you look at the predictions at that time and what the trajectory has been since then, unfortunately, no model has ever been able to accurately predict what is truly happening. There is the right direction, roughly, but the scale of difference is often actually completely through the roof. And we tell them, we cannot predict what the next geopolitical event is going to create, what actually trade interventions are going to be required, what new supply route is going to disappear because we disagree with what has happened. It's impossible to do.
And everyone is trying all the time. Okay, well, I generally try to get onto the topic of deep sea mining before podcasts run out. Is there anything else that you feel relevant to the conversation about criticality that we should touch on before getting into deep sea?
Maybe just a closing remark is that more often than not, criticality comes from a global supply chain perspective and the different transformation of the products. It's not just the mining. It's not criticality is not a geological problem. It's a geopolitical and optimization of supply chain issue where concentration of means of production or transformation at all the different stages creates bottleneck or perceived problem for an entity of dependency that might be out of its comfortable spheres of influence. That would be kind of closing remark on the problem of criticality.
Great.